Practice interpreting slopes and y-intercepts. Lesson objective: interpret the slope and the y-intercept of a regression equation. Let's begin. If you recall, this is the regression equation. Y hat, that's to tell the reader that this is the predicted value of y, equals b, the y-intercept, plus the slope m times the value of the explanatory or the independent variable x. Now sometimes technology will write mx first then b. Sometimes technology will write the b first then the mx term. So just remember that the slope is always multiplying the x variable. That will be the coefficient, will be the value of the slope. The constant will always be the y-intercept. Interpreting the slope, if you recall, the slope is the change in y over the change in x. It's rise over run. Now in statistics, we normally have the change in x be a 1 and the change in y will be the value of m. So as x goes up by 1, how is the y changing? And that will be the value of the slope. If m is negative, y will decrease every time x increases by 1. If the slope is positive, the y values will increase as x increases by 1. So here's our template. As the x variable increases by 1 x unit, the units for the x variable, then the y variable will either increase if the slope's positive or decrease if the slope is negative. By how much? Well, it's the value of the slope, m, and the units will be the y units, and then we add on average. To interpret the y-intercept, we can think of the y-intercept as like the initial value of y, the starting value of y, and that's going to happen when x is 0. So the y-intercept is a point. It's not a rate of change like the slope, it's just your initial value. It's the value of y when x is 0. The template for the interpretation of the y-intercept would be, it is the predicted value of y, the response variable, or the dependent variable, when the x variable, when the explanatory variable is 0. And if we don't have any data near 0 for the x values, a lot of times it doesn't make any sense in the terms of the problem. But that is okay. We can still interpret it, but it may not make sense in that situation. Let's do some examples. Suppose a market researcher is interested in studying the relationship between the odometer reading on a used car and its selling price. He collects a random sample of 150 cars and he uses technology to create the following regression equation. Selling price equals 8,500 minus 0.0325 times miles on the odometer. A. State the independent and dependent variables, include the units. B. Interpret the slope in the context of the problem. C. Interpret the y-intercept in the context of the problem. Does your interpretation make sense? Part A. The independent variable is the odometer readings and it's measured in miles. The units are miles. The dependent variable is the selling price in dollars. Now that wasn't clearly stated that it was in dollars, but when you think about buying a car, the units would be dollars. Part B, the slope is negative 0.0325, and then the units would be dollars, and that's over the change in x, which is 1 mile. So to interpret this, we would say, as the odometer reading increases by 1 mile, the selling price decreases because it's negative by $0.0325 on average. Part C, the y-intercept is $8,500. The interpretation of the y-intercept, when the odometer reading is 0, the predicted selling price is $8,500. Does this make sense in terms of the problem? I would say an odometer reading of 0 is not likely for a used car, so no. Let's do another problem. A researcher wanted to know if soft drink consumption is associated with a lower bone mineral density in men. The least squares regression equation was computed for a large data set. Bone density equals negative 0.003 times consumption plus 0.887, where bone density is measured in grams per square centimeter and soft drink consumption was the number of cans per week. A. State the independent and dependent variables. B. Interpret the slope. C. Interpret the y-intercept. Part A. The independent variable is soft drink consumption, and the units are cans per week. The dependent variable is the bone density with units grams per square centimeter. We know bone density is the dependent variable because it is the variable that was isolated in the regression equation. Part B. The slope is negative 0.003 grams centimeter squared over 1 can per week. To interpret the slope, we would say as the consumption increases by the unit 1 can a week, the bone density decreases because the slope is negative by 0.003 grams per centimeter squared on average. Part C, the y-intercept is 0.887, and the interpretation would be as the soft drink consumption is 0 cans per week, the predicted bone density is 0.887 grams per centimeter squared. This is likely a reasonable answer for this situation, as there are people who do not drink soft drinks, so 0 is a possible answer for the independent variable. It is in the domain of the x values. Let's do another example. A researcher collected data representing the number of days absent and the final grade as a percentage for a sample of students in a statistics course at a local university. The regression equation is final grade equals negative 2.8 times the number of absences plus 92.1. What are the independent and dependent variables? Interpret the slope, interpret the y-intercept, and finally predict the final grade for a student who missed 5 classes. So whenever we're doing regression, we always want to first figure out what is the independent and what is the dependent variables. When you're not sure and you're given the regression equation, the variable that is isolated, the final grade, in this case, that is our dependent variable. The independent variable is the number of absences. So A, number of days absent, is the independent, the explanatory, and the dependent or the response variable is the final grade written as a percent. Now, what are the units for the number of days absent? Well, of course, that would be days. This is a discrete variable. Part B, the slope is negative 2.8% per day absent. So the interpretation would be as the days absent increases by 1 day for each day absent, the final grade decreases by 2.8% on average. That is the interpretation of the slope, and this clearly explains as the x increases, how much is the y increasing, or in this case decreasing. Part C, the y-intercept is 92.1%, so that means when the number of days absent is 0, the predicted final grade is 92.1%. This is a reasonable value for this situation, as there are students who most likely have not missed a class. Part D, the final grade for 5 days absent would mean x is 5. We want to find y. So we take negative 2.8, multiply it by 5, and add 92.1, and we get the predicted final grade of 78.1%. Let's do our last example. A researcher studied the relationship between the total number of touchdowns made by top-paid National Football League (NFL) quarterbacks and their salaries. The regression equation was computed to be salary equals 4,393,649.84 plus $320,510.26 times the number of touchdowns. So the independent and dependent variables, the independent salary is dependent upon the number of touchdowns. Now in this case, the y-intercept is this value. It's given first, and here is the slope. And again, we always want to double check that whatever number is multiplying our x value, that will be the slope. This is the constant. So part A, the total number of touchdowns is the independent variable, and the units would be a touchdown. The dependent variable is salary, and that's given in dollars. Part B, the slope is a positive $320,510.26, and that's per touchdown. So as the number of touchdowns increases by 1, the salary increases by this amount. So the interpretation of the slope would be as the total number of touchdowns increases by 1 touchdown, the salary increases, because it's positive, by $320,510.26 on average. Part C, the y-intercept is $4,393,649.84. Woo! So the interpretation of the y-intercept would be when the number of total touchdowns is 0, the predicted salary is $4,393,000 and some change. Now, does this make sense in terms of the problem? I would say this is not a reasonable value for this situation, as you're not going to be a quarterback very long if you haven't thrown any touchdowns. Part D, if r is equal to 0.58 and r squared equals 0.34, what can we say about the strength of the association between touchdowns scored and quarterback salary? How much of the variation in salary can be explained by the number of touchdowns scored? If you recall, r is our correlation coefficient, so it's a positive number, and 0.58, that is a moderate correlation. R squared, the coefficient of determination, this is measuring spread, is 0.34. So this tells us the percentage of variation in the y variable, which in this case the y variable is salary, that is explained by using the number of touchdowns, or the regression equation. The value of r being 0.58 suggests that there is a positive, moderate, linear association between the number of touchdowns and salary. It's not strong, but there is a relationship going on. R squared is equal to 0.34, which means 34% of the total variation, and that's another way of saying spread, and quarterback salary is explained by the regression equation or model. This also means that 66% of the variation in salary is not explained by the model. These two put together suggest that there is a relationship, but it is not a super strong relationship. Thanks for watching.